Hey everyone. This is kind of a weird talk for me because it's not like a pure DeFi research type of thing. It actually is a lot of conversations I've had with a bunch of people of how decentralized models can improve more quickly, and where you can draw some inspiration from things on chain, whether in DeFi or not. So, a natural question is we've seen these kind of very fast moments where single innovations in open source AI suddenly take the world by storm. People get really obsessed with them. I'd argue that, since DeepSeek's launch for R1, maybe the open source community has taken a couple steps back. It hasn't had kind of some of the improvements that the closed source models have had. Sorry. And so let's actually talk about different ways that you can improve the open source model stack and how it looks schematically. So first, let's talk a little bit about reasoning language models. So if you've used any of the O series from OpenAI, any of Gemini 2.5, any of the newer models, Claude Thinking, you have used a reasoning model where you'll see a sequence of steps that's generated for you. Let's say it says, hey, I'm asking a prompt, what are the steps that it's using to construct an answer for me? And compared to a standard language model, what happens is these steps are sort of iteratively constructed, and it's almost like asking sequential prompts back to the same model. And the main thing that guides this process are reward models. And so these reward models are actually extremely useful for generating really small models. So DeepSeek in particular chose a set of rewards that was able to make training much faster and inference much faster for open source models. And this is sort of where the crypto insight comes in. How do you choose these rewards? How do you think about what these kind of rewards should look like? So let's kind of walk through an example of a prompt to kind of see what these rewards actually look like mechanically. So suppose I say, hey, I want to know what the compound interest I'm going to pay on $1,000 of principal over 3 years at a 5% yield is. So maybe that creates another prompt that gets sent back to the same model that says, okay, let's write down the compound interest rate formula. So A is sort of the total interest. And I get a little reward for constructing that subsequent prompt. Next, I say, okay, actually try to solve this problem with those numbers and get an answer. And you get another reward. Next, you say, okay, let's actually remove the principal because the initial prompt only wanted interest. You get another reward. And then finally, you say, okay, this is the final output. So this sequence of steps is guided by these little rewards that are given to the model, right? That's what these R sub i's are. And this process is in general called chain of thought reasoning or in context learning. So one of the main things about DeepSeek is that it used this sort of novel RL algorithm for very sparse rewards. So rewards that are basically zero everywhere except for right answers and very close to right answers. This means that in some ways it was able to learn how to use less compute by optimizing the rewards that were used in the model. This reduces the human annotation needs and it sort of expands on existing known reinforcement learning algorithms quite a bit, despite it being simpler, which is like, it's sort of deceptively simple. And I think there's currently this race to understand why theoretically it's so much better. So just I'm not sure it's displaying correctly, but what these kinds of systems do is you write some sort of expected loss as a function of the reward, and then you look at how much better your score on an evaluation grows. Schematically, what this looks like is you have a base LLM, you sample a bunch of queries that you want to improve on. Then you have a reward model that effectively adds a score for the subsequent prompts. So in the previous example, you could see the rewards for each of the steps in computing the compound interest. And then from that, you estimate what is known as an advantage. And the advantage is sort of, hey, did the reward model push me in a direction better than the base model would have given me if it just gave me a one-shot answer? And that's sort of the important key to using gRPO-like algorithms. Okay, so I'll try to skip most of the math. I just kind of cribbed this slide from another talk that was more about the details. But how do you model this system formally? So you have a sort of set of states of prompt output history. You have a set of actions, which are the set of these reasoning steps that are constructed. You have a set of transitions that's defined by the language model, the pre-trained model. You have a set of rewards, and this is the most important part. And then you have sort of discount, which is, how much should I trust my intuition right now versus later. Policy takes a set of prompts and outputs and generates a distribution over actions, i.e. next token. And your goal is to optimize the optimal policy. I'm not sure why some of the symbols aren't correct, but okay, so this is all classical stuff. So now you might say, okay, well, whatever. We've known about MDPs since, well, probably the 60s. And why is it all of a sudden working so much better in these models? So in the last 3 to 4 months, there's been a ton of research on how do you improve the DeepSeek reward model. And we found a bunch of papers that are saying things like, A, you can use random rewards and get almost the same performance, which is not good because that sort of says the rewards don't work. B, you could say, actually, you can learn the rewards dynamically, almost like a transaction fee model in the blockchain, where you're sort of updating sort of prices based on how well the rewards are working. And then C, there's a certain notion of like randomly perturbing the DeepSeek sparse rewards actually gets you faster conversions. So what all three of these things show is that this reward design space, how you choose rewards to make these models meet some objective, is actually still a very open problem. And it's one of the most important problems for open source models right now. So I want to just give you an analogy, and I'm talking about this thing abstractly, but what does the kind of reward design problem look like? So let's just take a task that maybe you might give a child. Ride a bicycle 100 meters, make a U-turn, and ride back. So one way of kind of incentivizing someone to learn that sequence of steps is you give them what are known as procedure-based rewards. You give them a reward for each step they take. So maybe for learning to balance, you give them a reward of 1. For learning to pedal, you give them a reward of 1. Learning to brake, you give them a reward of 1. For each meter they cycle, you give them a reward of 1. And so in these procedure-based rewards, you might be able to get some partial rewards without making it through. On the other hand, you could give what are known as outcome-based rewards. So I give you 1,000 units of reward, $1,000, 1,000 coins for completing the entire task, but you have to figure out the intermediate steps. And what you can view what the DeepSeek algorithm is doing is it's actually giving outcome-based rewards, but in the process, you actually are learning procedural rewards. So I'm basically saying, I'm going to give you 1,000 coins for getting to the endpoint. But if you happen to find an endpoint, it turns out you will have on the way have learned procedural rewards for each step that got you there. And the fact that it's able to do that with the outcome-based rewards are sort of cheaper. You could imagine you only have to select and say something like, did this code actually output the task I wanted? The procedural rewards are like, did you write a for loop correctly? Did you write all the variables correctly? And so the interesting thing that you should take away is if you design the rewards correctly, you can actually make these models extremely sparse. And that means they'll run faster, they'll run better on embedded hardware. So here, an example of the types of rewards DeepSeek uses is if you have a math proof, it'll give you +1 for complete proof, plus 0.5 for some missing steps, and then 0 for everything else. This is a very minimal reward. If you actually look at the early OpenAI papers in 2023, for doing kind of some of the IMO and math contest problems, they actually had paid people to annotate existing IMO problems and say like this step counts as 5 points, this step counts as 1 point, and it took hundreds of thousands of people over many years to kind of generate these data sets. Whereas in the DeepSeek case, they chose really simple rewards and it worked. So what does this tell you we can do in the decentralized space? So crypto networks are actually really good at making contests with rewards, making systems where people can try to optimize a particular reward function in a public way and get rewarded for it. So you could imagine a system where users can submit these kind of reward functions. And based on that, they actually get paid out on whether they improve evaluation time, whether they reduce the actual amount of reasoning steps needed to get to the right answer. And in general, this actually looks a lot like a DeFi system, except you have a sort of weird oracle for scoring, which is the evals you're using. There's another sense in which a lot of the RLVR, which are sort of the DeepSeek-like systems, these reinforcement learning with verifiable reward systems, look a lot like interactive proofs. So they have a sense in which I make a claim, I get a response, and based on that response, I get a reward. And after many of those rewards, I'm confident that I eventually get to either A, the right answer, like an interactive proof system, or B, I'm near the maximal rewards I could have earned. And so there's a sense in which a lot of crypto protocols are designed around very similar principles as these DeepSeek-like models. So the reason I bring this up is you could imagine actually doing this as a way of getting a crypto native way of discovering optimal on-chain rewards. It's almost like point systems in DeFi. And so there's sort of a sense in which you could imagine people competing to improve these DeepSeek-like rewards, and you paying them based on how well their contribution works. So there's obviously a ton of problems in terms of attribution, but what one can show is that you don't need that complicated of reward systems in order to actually get relatively close to optimal. And that's sort of, I just want to give you a kind of flavor of something that people in open source AI are doing in practice that really looks a lot like what people in crypto do, and hopefully there is actually cross-pollination of those lessons. I ended very early, so that's it.